All right, so let's now answer part C here, which says the ages of the riders in the Tour de France are also approximately normally distributed. A recent survey found that 16% of the riders were under the age of 25.5 years and 2.5% of the riders were over the age of 33 years. Using the 68, 95, 99.7 rule, find the mean and standard deviation of the normal distribution modeling this data. So a little bit of a tricky question here, and normally, where people fall down on these types of questions is they don't know where to begin. But remember, do what you can. Do what you can. So what am I going to do here? Well, I've been told that something is normally distributed. It's now ages. So previously, we had talked about how, the distance in kilometers is normally distributed. But now we need to do another one for age. So I'm a simple man. I see normally distributed. I draw for myself a normal distribution. That is my mean that we don't know. We're trying to figure out the mean, and we're also trying to figure out the standard deviation. But I know that the standard deviation, you got 3 down and you got 3 up. So I'm just doing what I can. Nice. The next thing I would do is I would look at the pieces of information that I'm given here. So the first thing I'm told is that 16% of the riders were under the age of 25.5 years. So 16% are under the age of that. Well, if I look at my bound reference here, I know that if I add that and that and that, that will all add up to 16%. So, and I'm talking about, 16% are under, right? So if we go over here, 16% were under the age of 25.5 years. Whoopsie daisy. So that must mean, I come over here, that this here has to be 25.5. So I'll come back here, we'll come here. So one standard deviation down will be 25.5. What else am I told? I am told that 2.5% of the riders were over the age of 33 years. So 2.5 were over the age. So if I come over here, I know that if I add these two numbers together, I get 2.5%. So that must mean that right there will be 33. And again, it's over, so that's why I'm looking at this portion of the graph. So I come here. Okay, 2. This will be 33. So 1, 2. Perfect. Now, once I had done that, I looked at this for a bit. I'm thinking, all right, what am I now going to do? And then I realized, well, I'm after the standard deviation. And I know that, all of these bits, like the distance from here to here, each of these things are, equal length, right? So all I need to do now is say, well, what's the distance between there and there? So I went 33 minus 25.5. So I figured out the distance between there and there. And that was, let me write this down. So I went 33 minus 25.5, and that was equal to 7.5. And then I said, well, now I just need to divide it up based on, how many divisions I have here. And how many divisions do I have? Well, I have 1, I have 2, I have 3. So I want to break it up into 3 sections here. So I want to take that 7.5 and I want to break it up into 3 sections. So I go 7.5 divided by 3. So divide by 3. And I'm going to end up with 2.5. And hopefully you can now see why this is so helpful, because I can now check what I've done. So I'm saying if I have 25.5 and I plus onto it 2.5, I'm going to get 28, which would be my mean. Then I'm going to plus 2.5 onto it again, and I'm going to get 30.5. And then I'm going to plus 2.5 again, and now I should get 33. And sure enough, I do. So I've just solved it. That right there, that number right there, that's my mean, and my standard deviation is 2.5. So now we can come up here, and we can go, the mean, let me come here. I'm going to say the mean is 28. I'm going to say the standard deviation is 2.5. It's worth 2 marks, so I'm assuming 1 mark per each of these. So yeah, that's the mean, that's the standard deviation. That's how we figured it out. We just drew out what we could. So remember, when you do face these questions like this, just do what you can. Let's just look at our examiner's report before we move on. Mean is 28, standard deviation is 2.5, and we are done. Hopefully you found that helpful.